You're recording. Hi, say hi.
Hi.
Okay.
Now, 160 pounds. Alright, foot and a half. Alright, now we're at 2 foot. Alright, now we're going to 2.5. Broke it. 160 pounds, broke it 2.5 feet.
Sweet.
Going again. Another breaking point.
Alright, out to the first foot. Alright, I'm going to 1.5 feet. Still not breaking. Going out to 2 foot.
Getting cracking. There we go.
Yeah.
And alright, going out to 1.5 feet.
Beam fixed at both ends, so all I have to do is go load, take the length and divide it by 8. That way we can figure out our M max, and this is where we know our bending torque. We can measure the distance and predict whether it's going to break.
Okay.
Alright, here we have our first break, our second break, and our third break. We have an average braking torque of 320 foot-pounds for the board. Knowing that, we know that our board is 3 feet across. 1.5 times 160 pounds, which is our load, is 240 foot-pounds. Our braking torque being 320, we know that it can support the 240 foot-pounds. Our M max, which is our bending moment, using our bending moment diagram, we know PL over 8, P being our load of 160 pounds, L being our length of 3 feet, and divided by 8 is 60 foot-pounds. We know that that is way less than what we will load on there, so we know that we'll support that. Knowing our braking torque is 320 pounds, he's only going to put 240 foot-pounds of braking torque here. We also know our M max, and we're predicting with the 60 foot-pounds for our bending max it will not break here. We have 2 supported fixed ends, 1 concentrated load in the center. As you can see, it is not breaking. Here, scenario 13, we have a beam fixed at one end, supported at the other. Our braking torque is 320 pounds. That's our average braking torque. Our braking torque for this is going to be 1 foot 5 inches times 160 pounds. It's 240 foot-pounds. It's obviously less than our 320 foot-pounds. Using that in our M max from scenario 13, we have 90 foot-pounds. Using this scenario, we predict that it will not break. Here we have a beam fixed at one end, supported at the other end. Using this scenario, we have our M max to be 90 foot-pounds and our braking torque to be 240 foot-pounds. Since this is 3 feet long, divide that in half and you have 1 foot, you have 1.5 feet. 1.5 feet times 160 pounds is 240 foot-pounds of torque. We're predicting our M max is 90 foot-pounds, so we're predicting using that it will not break. As you can see, 160 pounds of weight times 1 foot times 1.5 feet, 240 foot-pounds is not breaking. Using one supported beam and 1 fixed end.